Hello, my name is Shubsina and welcome to my channel. So today we will learn about another important topic of data structure, which is linked list. In the previous two videos we have learned about the arrays and the pointers. So today we will learn about linked list. Let's begin. So first of all, what is the introduction? Linked list is a linear data structure that includes a series of connected nodes. Linked list can be defined as the nodes that are randomly stored in the memory. A node in the linked list contains two parts, that is, first is the data part and the second is the address part. The last node of the list contains a pointer to the null. After array, linked list is the second most used data structure. In a linked list, every link contains a connection to another link. So what is the representation of a linked list? Linked list can be represented as the connection of nodes in which each node points to the next node of the list. The representation of the linked list is shown below. So from the diagram we can say that till now we have been using array data structure to reorganize the group of elements that are to be stored individually in the memory. However, array has several advantages and disadvantages that must be known to decide the data structure that will be used throughout the program. So why we use linked list over array? Linked list is a data structure that overcomes the limitation of arrays. Let's first see some of the limitations of arrays. The size of the array must be known in advance before using it in the program. Increasing the size of the array is a time-taking process. It is almost impossible to expand the size of the array at runtime. All the elements in the array need to be contiguously stored in the memory. Inserting an element in the array needs shifting of all its predecessors. So, why do we need linked list? Linked list is useful because it allocates the memory dynamically. All the nodes of the linked list are non-contiguously stored in the memory and linked together with the help of pointers. In linked list, size is no longer a problem since we do not need to define its size at the time of declaration. List grows as per the program's demand and limited to the available memory space. So how to declare a linked list? It is simple to declare an array as it is of single type, while the declaration of linked list is a bit more typical than array. Linked list contain two parts, and both are of different types. That is, one is the simple variable while another is the pointer variable. We can declare the linked list by using the user-defined data type structure. The declaration of linked list is given as follows: the struct node in data, struct node in point next to next. So what are the types of linked list? Linked list is classified into the following types: singly linked list, double linked list, circular singly linked list, and circular double linked list. So what do we mean by singly linked list? Singly linked list can be defined as the collection of an ordered set of elements. A node in the singly linked list consists of two parts, that is, data part and the link part. Data part of the node stores actual information that is to be represented by the node, while the link part of the node stores the address of its immediate successor. Second point is doubly linked list. Doubly linked list is a complex type of linked list in which a node contains a pointer to the previous as well as the next node in the sequence. Therefore, in a doubly linked list, a node consists of three parts: the node data, the pointer to the next node in sequence, which we can say next pointer, and pointer to the previous node, which we can say previous pointer. Then the third point is circular singly linked list. In a circular simply linked list, the last node of the list contains a pointer to the first node of the list. We can have circular simply linked list as well as circular doubly linked list. So what do we mean by circular doubly linked list? Circular doubly linked list is a more complex type of data structure in which a node contains pointers to its previous node as well as the next node. Circular doubly linked list doesn't contain null in any of the nodes. The last node of the list contains the address of the first node of the list. The first node of the list also contains the address of the last node in its previous pointer. Now let's see the benefits and limitations of using the linked list. So what are the advantages of a linked list? The advantages of using the linked list are given as follows. The dynamic data structure. The size of the linked list may vary according to the requirements. Linked list does not have a fixed size. The second point is insertion and deletion. Unlike arrays, insertion and deletion in linked list is easier. Array elements are stored in the consecutive location, whereas the elements in the linked list are stored at a random location. To insert or delete an element in an array, we have to shift the elements for creating the space. Whereas in linked list, instead of shifting, we just have to update the address of the pointer of the node. The third point is memory efficient. The size of a linked list can grow or shrink according to the requirements. So memory consumption in linked list is efficient. And the final point is implementation. We can implement both stack and queues using linked list. So what are the disadvantages of linked list? The limitations of using the linked list are given as follows. Memory usage. In linked list, node occupies more memory than array. Each node of the linked list occupies two types of variables. That is, one is a simple variable and another one is the pointer variable. The second point is traversal. Traversal is not easy in the linked list. If we have to access the element in the linked list, we cannot access it randomly. While in case of array, we can randomly access it by index. For example, if we want to access the third node, then we need to traverse all the nodes before it. So the time required to access a particular node is large. The third point is reverse traversing. Backtracking or reverse traversing is difficult in a linked list. In a doubly linked list, it is easier but requires more memory to store the back pointer. Then, what are the applications of linked list? The applications of the linked list are given as follows. With the help of linked list, the polynomials can be represented as well as we can perform the operations on the polynomial. Second, we can say that a linked list can be used to represent the sparse matrix. The third point is that the various operations like students details, employees details or product details can be implemented using the linked list, as the linked list uses the structured data type that can hold different data types. Using linked list, we can implement stack, queue, tree and other various data structures. Then we can also say that the graph is a collection of edges and vertices, and the graph can be represented as an adjacency matrix and adjacency list. If we want to represent the graph as an adjacency matrix, then it can be implemented as an array. If we want to represent the graph as an adjacency list, then it can be implemented as a linked list. A linked list can be used to implement the dynamic memory allocation. The dynamic memory allocation is the memory allocation done at the runtime. So what are the operations performed on linked list? The basic operations that are supported by a list are mentioned as follows. Insertion. This operation is performed to add an element into the list. Then the deletion. It is performed to delete an operation from the list. Then the display. It is performed to display the elements of the list. Last point is search. It is performed to search an element from the list using the given key. Now, coming to the complexity of linked list, let's see the time and space complexity of the linked list of the operations search, insert and delete. So, operations insertion is of average case time complexity O of 1, and in case of worst case time complexity O of 1 also. Then in case of deletion, the average time complexity is O of 1 and the worst case time complexity is also O of 1. And in case of search, the average case time complexity is O of n and the worst case time complexity is O of n also. So here n represents the number of nodes in a tree. The second is space complexity. So what are the operations? In case of insertion, the space complexity is O of n. In case of deletion, the space complexity is also O of n, and in case of search, the space complexity is O of n also. So the space complexity of linked list is O of n. So thank you. That's all from my side. Today we have learned about the linked list and its time complexity and the space complexity also, and the advantages and disadvantages of linked list, and again the types of linked list. But I must say the types of linked list, they each and every one, for example, if I show this slide, then you can see that single linked list, double linked list, circular single linked list and circular double linked list, they all have each and every linked list have unique data function, and that will be a very broad one, so that is not possible for me to explain to you guys. So that's why you need to just Google through it, and from Google you can see that they are all performed in menu driven programs. So whenever I will teach a menu driven program, then all this concept will be explained by me in a much better way. So that's all. Thank you. Till the next lecture. Bye bye.